All right, welcome aboard. This is going to be integration by parts, example number 1. We're going to break it down BRNY style right now. It's going to start with an integral expression. In this case, we have the indefinite integral of the ln of x divided by x squared dx. The first thing we need to pay attention to is figuring out how we know this is going to be an integration by parts technique. There's a couple dead giveaways here. We have an ln of x expression in the integral. That's one. And our second giveaway is that we have two functions in the integral that are both of the same variable. So we have ln of x up top, x squared on the bottom. That's two functions of x in the same integral expression. That tells us we're going to be integrating by parts. The standard form for your integration by parts is as follows. You have the indefinite integral of u v prime equal to u times v minus the indefinite integral of u prime v. So let's go ahead and get into step 1. What we're going to need to do is take each one of these functions of x and associate them, one of them to the variable u and the other one to the variable v prime. Now when you're choosing the u and the v prime, you're going to want to do it in such a way that whichever expression you pick for u is going to be easy to take a derivative of, and whichever expression you pick for v prime is going to be easy to take an integral of, because you're going to need to go from u to u prime and v prime back to v. So in this case, let's choose u to equal our ln of x, or our numerator function here. The derivative of ln of x, or u prime, is just equal to 1 over x. So that one's pretty easy. Next, we'll pick our v prime, and in this case, it's going to be 1 over x squared. In order to go from v prime to v, we're going to have to integrate our v prime, so it's going to be the integral of 1 over x squared. The integral of 1 over x squared is equal to the integral of x to the negative 2. And then we're going to take the integral. We'll use the power rule here, so we'll take x to the negative 2 plus 1 divided by negative 2 plus 1. That's going to leave us with x to the negative 1 divided by negative 1. And then we'll just rearrange this to clean it up. It's going to be equal to negative 1 over x. So now we have our four variables. We'll move on to step 2. Step 2 is going to be finding the uv component right here. So u is ln of x, and v is negative 1 over x. So u times v is equal to ln of x times negative 1 over x, which is equal to negative ln of x over x. That takes care of our uv. Now we'll move on to the indefinite integral of u prime v, which was this component up here. We're going to ignore this minus sign for a second and just take this integral down as positive. U prime, 1 over x, and v, negative 1 over x. So this is going to be equal to the indefinite integral of 1 over x for our u prime times negative 1 over x for our v. We'll do some simplification here. That's going to leave us with the integral of negative 1 over x squared. We'll go ahead and pull the constant out of the integral. It's going to leave us with negative integral of 1 over x squared. And now we're just going to go ahead and use our power rule again. It's going to leave us with negative x to the negative 2 plus 1 up top, divided by negative 2 plus 1 on the bottom. When we do that math out, we come out with negative x to the negative 1 divided by negative 1. These two negatives will cancel and become a positive, and that x to the negative 1 will just drop it to the bottom, leaving us with 1 over x. So the integral of u prime v is equal to 1 over x. So now we have the two components that we need, and we'll just go ahead and put them together. U times v was negative ln of x divided by x, so negative ln of x divided by x. And the integral of u prime v was equal to 1 over x. And before I told you that we were ignoring this minus sign, but now we'll bring it back. So it's going to be minus 1 over x. Add plus c for your constant of integration, and you are all squared away. And that's integration by parts, BRNY style.